Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to wrap up our overview of the different kinds of vector data by talking about the last type, which is polygons. And I want to give another example. So let's say that you've done the fire hydrants, which we measured each hydrant with a single location, so it was a point. You were given the task of doing the roads, where you started at the beginning, you went along the road and occasionally took points. So each road was represented by multiple coordinates, therefore it was called a line. And you get back to the office and your supervisor says, okay, now you're going to go out and you're going to give me the lakes within the county. So we've done fire hydrants, which were points. We've done roads, which were lines. And now we're going to measure the location measure and map the location of lakes. Okay? So you sit back for a second and you say, well, I did fire hydrants by standing on top of one with the GPS, getting a single point for each hydrant. I did roads by standing at the start, getting a point, walking some distance, getting another point, walking some distance, getting a third point, walking to the end and getting a fourth point. And by connecting those together, I was able to do roads. What if I do something similar for lakes? And the answer to that is absolutely what you would do, with one key difference. So with lakes, what we're going to do is we're going to do something called Polygon. Let me try to make that a little cleaner. Called Polygon vector data. And with Polygon vector data, what we do is each discrete object is represented by, in this case, 4 or more coordinates that must form a closed loop. Okay? So we've upped it from 2 in the case of line to 4. And now we have the specification that it must form a closed loop. What do I mean by that? So let's go ahead and walk through our example of measuring lakes. So I think for the sanity of explanation, I'm going to just have a singular lake. So we have lake 1 that we are going to go out with a GPS unit and we're going to measure various locations around the lake. And then we're going to come back into the office. Let's try and make that just a little bit straighter. Right. And just like last time, I cannot draw a straight line today. Just like last time, right? We're going to come back into the office and we're going to visualize the data. Right, by plotting the coordinates that we measured. So you go out in the lake, to the lake, not in the lake, to the lake, because you're going to stand along the edge. You don't want to get wet and go for a swim. So we stand out on the edge of the lake, right? And just like with the road lines, right, you're going to get your start X and your start Y. Right, let's say for the sake of argument, this is going to be 5 and 5. Okay, so you start at the start of the lake, You walk along the lake edge for a little while, and you get an x2 and a y2. And let's say the x2 is 7. Oh, let's say the x2 is 8, and the y2 is maybe 6. So we haven't gone up that far, but we've walked a fair amount in the x direction. So you get back to, so you keep going, you go x, you go x3, y3, take some coordinates. Maybe now you've taken, it turned a little bit, so you haven't gone that far in the x direction, but you've gone a ways in the y. You walk a little bit more, you take another point, x4, y4. And now you've sort of turned back. So you started to turn back. So now you're at maybe 7 in the x, and you've gone north just a little bit, and you've gone maybe, let's say, 17. You walk a little bit farther, you get one more point. Let's say we grab one at x2, y starts to come down 2, so you're down, let's say, 12. And then you walk a little bit more. Whoa. You walk a little bit more, and you end up back where you started. So your end x and your end y are 5 and 5. Okay? So we now have one. Actually, let me number these. So we now have, right, 1, 2, 3, 4, 5, 6 coordinate pairs measuring one object, right? So a singular lake object is being represented by 6 coordinate pairs. So you come back to the office and you generate your visualization. Again, what we're going to do is we're going to simply plot all of the points that we measured, all of the coordinates that we measured. So we're going to start with 5, 5, which we're going to say is like right here. Right. Next point, we're going to go over to 8, and then we're going to go up to 6. Right. And again, not necessarily perfectly to scale in terms of this coordinate system here. We walked a little bit farther in the y and the x, but we shot up in the y. So this is going to be 9, 13. Right, then we started to come back a little bit, still increasing in the y. So this is going to be 7, 17. Right, then we went 2, 12. So we're like right here. Right, and then we finally went back to the end, 5, 5. And so what we're going to do is, just like with the line, what we're going to do is we're going to connect all these points together. Right? Now this is where the must form a closed loop part comes in handy. Because if it has to form a closed loop, what that means, and I'm going to make a note of this here in let's say in yellow, right? Must form closed loop means start and end coordinates must be the same. Right? That's what it means to form a closed loop. Is that if we started at 5, 5, as we measure our coordinates around the object, we have to end at the same place that we started. So in this case, 6 had to be equal to 1, which it was. And so if we look at this object that we've created here, right, we see that we formed a closed loop. And what this allows us to do is this allows us to actually have an area, right? Let me make a note of that, right? We created, let's make that look a little bit more legible, right? We created an area, right? An enclosed loop forms an area. When we have an area, we have a polygon, right? So polygons give us areas. Okay? So think about that for a second. Think about the fact that we now have an area. And in the next video, I'm going to sort of highlight and explain why it's important to differentiate this closed loop polygon versus the open meandering line versus the single coordinate point, and the different types of information that we can get from and retain in those different types of vector data. The other thing I want to point out is why it has to be a minimum of 4. So let's give ourselves just a little bit of space here and answer the question of why min of 4 chords, right? And what I want to do is I want to give an example, right? If we have one chord, if we have 1 point, let's say 5, 5, right? Can't form a closed loop, right? There's not enough points there. What about 2 points? Say 5, 5, and 7, 7. Well, again, right? Can't form a closed loop. Right, it's a line. Now, here's the part where you might be thinking, well, what about 3 points, right? We can have a triangle. So let's actually draw that out, and let's think through why we can't do this with just 3 coordinates, even though when you think of geometry, you think of a triangle having 3 points. Let's think this through. So if we start at 5, 5, right? Then we go from 5, 5 to 7, 7. Then we go from 7, 7, let's say, to 6, 6, right? So if we draw that out, right, 5, 5 goes to 7, 7. Well, actually, hold on. Let's draw this a little more accurately. Right, 5, 5 goes to 7, 7. 7, 7 goes to 6, 6. Right? Do you notice there's a gap here? Right? And this gap is because we have not explicitly told it to close the loop. Right? Because you have to remember, when we're dealing with vector data, what it's doing is it's literally tracing a line along the coordinates from one to the next as we give them it, or as the computer gets them. So it's going from 5, 5 to 7, 7. It's going from 7, 7 to 6, 6. And since we haven't told it anything, it's just going to stop here. It's going to make a 3-point line. We have to feed it 5, 5 again, so that it will then say, okay, I'm going to go from 6, 6 to 5, 5. I'm going to fill that gap in with an extra line to form a closed loop. Right? So this is why you have to have a minimum of 4 points, because a triangle having 3 points defining its sort of vertice turns here, right? The only way to get this additional line is to tell the computer, hey computer, finish this off. Don't just leave this as a line, finish it off with a polygon. And that's why I said up here, right, to form a closed loop, the start and end coordinates have to be the same. So hopefully that makes sense. And as always, if you have any questions, please reach out. Thank you.